Okay, year 12. So today we're going to look at geometric series. So if you remember from last time, a sequence is just a sequence of numbers, and a series you get when you sum the numbers in the sequence together. So last time we looked at the formula for the sum of an arithmetic series, which is this. Then there is a new formula for geometric series. So this is one of the formulas that you can use. I would suggest you get this written down now. This formula will be given to you in the formula booklet in the exam. Obviously, it's useful if you don't keep checking it and you notice that. You can also use this formula. This version is not given to you in the exam. You're only given the one on the left-hand side. As like a note, this version, the version on the left, is easier to use if R is less than 1, whereas this version is easier to use if R is greater. It doesn't matter, they both work, they're both the rearrangements of the same thing, but that's just kind of a tip. You could be asked to prove where this formula comes from. So this is in the textbook, but I just want to talk you through it here. So step one is just to think about, well, the sum of all the terms in the sequence, the first term is A, the second term is AR squared, all the way up to AR n minus 1. If we multiply that sequence by R, then we get the following. Then, if we subtract sequence, let me just call them something. If we call this sequence 1 and this sequence 2, if we do sequence 1 subtract sequence 2, we get this. We get S of n minus RS of n equals A minus ARn, like that. Then we can do some factorising. So if we factorise both the left and the right hand sides, we get this. And therefore, to find S of n, we just divide by 1 minus R. And so that's where the formula comes from. It is useful to get that learned because they could ask about it in an exam situation. Good news is actually applying that formula is more straightforward than proving it. So here, find the sum of the first 10 terms. So first of all, here A is going to be 3. R is going to be 2, and N is going to be 10 because we're looking for the first 10 terms. So for S of 10, and here because R is greater than 1, I want to use this formula. It would make sense for me to use this formula. So it will be 3, then R is 2 to the power of 10 minus 1, all over 2 minus 1. I then just input that into my calculator. And when I do that, I get 3,069. So that's the sum of the first 10 terms. The second one, let's begin by writing out our values. So here A is 4, R is 1/2, and again, because we're looking for the first 10 terms, N is 10. So then S of 10, and this time round, R is less than 1, so I'm going to opt for using this version of the formula, and it's going to be 4 brackets 1 minus 1/2 to the power of 10, all over 1 minus 1/2. So when I input that into my calculator, I get this. Blah, 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 blah. So let's just call it 7.99. And that's how we input into that formula. A slightly harder example, year 12. Find the least value of n such that the sum of this series here to n terms would exceed 2 million. So first of all, let's begin by identifying A and R, etc. So A is going to be 1 and R is going to be 2. Now, because R is 2, I would be inclined to use this formula here. So I can write 1 bracket 2 to the power of n minus 1 all over 2 minus 1, and we want that to exceed, so be greater than 2 million. After that, let's just simplify that left-hand side a bit. Simplifying the left-hand side gives this. I would then add 1 to both sides. So 2 million and 1. Then, because it's 2 to the power of something, we can log both sides. Lost count how many zeros I need. All right, 1, 2, 3, there we go. So then, using our laws of logs, we can rewrite this as n log 2. And therefore, to find n, we would divide by log 2. Inputting that into my calculator gives, 1 second, so right, we're doing log of 2 million and 1 divided by log 2 gives this. And so therefore it's going to take 21 terms. The 20th term won't exceed it. When there's 21 terms, it will do. So that is our final answer. With that in mind, have a go at exercise 3D now. As ever, feel free to skip on some of the harder questions near the end if you feel quite happy with this.